All right, so this equation is a little different than the last couple of examples because it has a leading coefficient. That's the 3 here in front of the x squared. So our first step in these situations is to see if this 3 can be factored out of all of the terms as a GCF. And in this case, we clearly can't. So that means we need to factor by grouping. So remember how that works is we look for two missing numbers. And these two missing numbers have a product that's the same as the product of the first and the last numbers here. So we want our two missing numbers to have a product of 6. So if we call our two missing numbers A and B, it would look something like this. And furthermore, these two missing numbers have a sum of -5. That means if we add these two missing numbers together, they give us -5. So from these clues, we know that if two numbers have a positive product, a positive 6, and a negative sum, that -5, they must both be negative. So let's list pairs of negative factors of 6. So my first example, my first pair of factors are -1 and -6. And they certainly multiply to a positive 6, but when we add them together, we get -7, so they can't be it. So next, we have -2 and -3. They definitely multiply to a positive 6, and when we add them together, we get a -5, so they are today's lucky winners, -2 and -3. That means we can then go and replace this -5 with -2 and -3. And I'm going to put the 3x in there first, but I absolutely could have put the 2x in first. Remember, when we are factoring by grouping, the order of these two missing magic numbers here in the middle doesn't matter. It works either way. So I'm going to group them and then look for GCFs among the pairs of numbers in the parentheses. So in the first set, I can pull out a 3x. And that leaves me with x minus 1. In the second set, I can pull out a -2. Remember, when there's a coefficient on this x here, we need to pull out that's negative, we need to pull out the negative also. So we'll pull out a -2, and that leaves me with x minus 1. And I continue the factoring here by pulling out the -1. Pulling out the x minus 1. And what's left is 3x minus 2. And so now I just need to set each one of these, I need to use the 0 property and set each one of these binomials equal to 0 and solve for x. So the left side goes pretty quickly, and we see that one of our answers is 1. The right side is a little different because we have a coefficient on the x, but that's okay. It will add one extra step. It'll add one extra step, and it won't be that big a deal at all. So here we have 3x equals 2. The extra step involves dividing each side by 3. And when we do that, the 3's cancel over here. And I see that x, the other solution, is 2/3.